one function.
Okay.
All right, this is going to be fun. Writing your own testing suite. Crazy. I can't believe anybody wanted this.
What?
I don't know. Writing your own testing suite.
It's literally to answer this question.
Huh?
It's literally to answer that question.
What question?
The question you just answered.
Kind of. I mean, I think you asked me more about like a philosophical testing question, like how should one?
Put me on the other one.
Like, no, but you broke the tie, so nah, it's cool. This is a good one. This is a good one. Okay.
Broke the tie. I was the only one that like voted for that one.
No, 3 people voted for writing your own testing suite.
Which, I mean, technically we already did that last week.
No, I mean that was more about like error checking, wasn't it? The last lecture I gave was about.
Well, Bonnie did like test-driven development.
Oh, sure. That's okay. What is this? What is happening? What is this noise? It's like I'm getting a call, but I don't know what that is. Yeah, go away. Cool. Do we got a projector yet? Go, projector. You're good.
Tie again right now if you like.
Well, but according to what I see, there's no more tie, right?
Well, if I change my vote, it will be.
Well, it's too late now.
All right.
I'm already ready for this. Okay. And let's share screen here. All right, good morning, everyone. Cool. All right, so this ought to be fun. I just wanted to give folks a better idea of what's going on inside of Mocha and Chai. So I figured we could spend some time just making our own Mocha, making our own Chai, so you can get a sense of how those tools work. Does that seem useful? Yeah? I don't know if anyone knew what that was. So if that's not useful, we could switch to some SQL stuff. I guess, see, now there's 3 ties. Anyway, does this seem the most useful to everyone? Is there anybody on Slack?
Yeah, I also voted for that.
For which one? Okay, cool. Let's do it then. All right, sweet. So let's look at, let's make an example using Mocha and Chai. So we'll create a little npm package here. And let's just use a canonical example. All right, so we've got, let's see, we've got our calculator here, and then we have tests for that calculator. And this uses Mocha and Chai, so we'll just be able to say, describe the calculator, and then we'll be able to describe calculator.add. Can everybody see this? Yeah? It should, let's see. It should take 2 numbers and return their sum. And so we'll probably need to require the calculator. And we'll say like expect calculator.add 10 and 5 to equal 15. And we don't even have expect yet, right? So const expect. This is the other library that we'll be making a copy of. Yes?
Said calculator.add, but you typed calculator.call.
Oh, Jesus. Thank you. Cool. So this isn't going to work. And it just says can't find calculator because it's actually up one directory, right? Up out of the test directory down to this file. And now it should say like calculator.add is not a function. Cool. So we've written our first test for the add function on the calculator object. We can come in here and we can say module.exports.add equals a function that takes A and B and returns A plus B. And now our test should pass. Boom. So this is Mocha and Chai, right? Everybody's used this before? Who's watching this? Cool. All right. So we've got two major things we're going here. Mocha and Chai are two separate libraries. Chai is the thing that gives you access to this expect object that lets you make expectations like this. You can actually just use this all by itself, right? So if we just go get expect in a node console, we can say expect 1, 2 equal 2, and we'll get an error. That's an assertion error. If we say expect 1 to equal 1, we get no assertion error. We get back this assertion object, but the return value is not usually really ever used except for in this chaining here. But so this expectation library, all its job is to look at the expectation that you've described and then to raise an error if it's not true. Otherwise, do nothing, right? So if we come in here and we say, add another one here that we expect 20 plus 7 to equal 27, this is going to pass 2, right? But let's say we had the first one was wrong, right? That's going to raise an error, which is going to fail our test, and this code never actually executed. Is that clear? Because this raised an error. Because its expectation was not correct. So all expect does is raise an error if the expectation you're expressing is incorrect. So we're going to work on these two things. We're going to create, oh, so sorry, that was expect. The other thing we're going to build is Mocha, this framework that allows you to have a describe and an it block. Okay? So we're going to work on those two things separately. Yeah.
So when we have another expect, like another describe function that has another test, and then let's say like the first one failed, but the second one actually passes, can that still run, or it only fail because the two expect functions decide the same describe, decide the same it function?
I don't understand the question. Could you ask me again?
So like we have like another describe function that has also.
Sure.
And let's say the first one.
Sure. So another describe. Well, you mean another it block?
Yeah.
So then we should say it should, throw an error when given an argument that is not a number. Yeah. So here's another test, right, where we can say if I give calculator strings, right, it should throw an error or something like that, right? So now you wanted to know, you had a question about two separate tests.
Correct.
Okay.
So in this case, because of line 7, when he said that the line 7 expect function is going to throw an error, it's not going to run line 8, but that's also going to run line 11.
Yes, it will. So we'll get into this because we're going to build this, but the very first thing that happens is this file, when this file executes, no tests are run, right? Lines 7, 8, and 11, those functions that those lines represent don't get executed at the beginning. The first thing that happens is we build a big array of all the tests in the entire test suite, right? We process all the test files and we decide like which are the individual tests that we're running, right? And then Mocha's going to run each test, and if one fails, it'll record that, print it to the screen, and go to the next test, right? So if we come in here and we have these two tests, let's make this one work. So we expect that when I run this function, passing, we'll only pass one in, pass in 10 and 5 to throw, you know, add only takes numbers or something like that. So it didn't throw an error, right? Because our calculator doesn't actually do that. So let's do that. If type of A does not equal number, throw new error. What was the error we wanted? Add only takes numbers. Okay, cool. So we have two passing tests in our test suite, yeah? What did I just do? Oops. So here's our calculator, and then here are the tests that we have for it, right? So if I make this one fail by putting the wrong expectation here, we see that this test failed, but we still ran this test, right? But we never ran this code, right? So you can illustrate that. Right, we get that little smiley face, but if this one fails, it's because this raised an error, so we never ran these two lines of code.
Why is that?
That's just how JavaScript works. When you throw an error, you start walking up the call stack, immediately halting future execution of all of those elements of the call stack until something catches that error. That's the whole point of an error, right? It's a feature of the programming language that allows you to change the way your program flows, right? You've got 27 steps to go through. Step 15 failed. You don't want to do step 16 and beyond. Step 15 failed. So in order to get out of the middle of that process, that procedure, we have something called errors, where we throw an error and something above that asked for that 27-step process to be executed can now receive and say, okay, you told me to do this 27-step process, but step 15 failed, so you decide what to do. I can't rescue from this error, right? So that's what that mechanism is utilized for this test suite, and we'll show how to do that because we're going to build that. Okay, so that's an example of Mocha and Chai. Let's get into making our own. Okay, so I'm going to, what should we name it? Let's name it, I don't know, what should we name our test suite? Those are totally taken. Those are totally taken. Okay, what's another rarer coffee? How about we do Red Eye? That's a coffee related thing. So this will be our test suite. And then our testing library will just be foam. Okay, great. And so we're going to actually need to make our calculator and our calculator dash test. So we have these three files in here. I'm not going to do all the work to break these out into separate NPM modules and stuff, but we're going to just use them as single file modules in here. But we can imagine how we might break this out into like a requirable and installable NPM module. So I'm sort of smashing those three things together, but it'll be all right. Go away. Okay, so first things first, let's copy over our calculator from the previous iteration into here. So we just have our add function. And our calculator test, we'll copy that over into here. And instead of chai, we're going to require foam. And I'm going to do this a little bit different than the way Mocha does. Well, actually, I'm not. Here we go. Okay, so we're going to get our expect syntax from foam now, and our calculator is going to still be from here. So if we try to run, so we don't have access to Mocha. We don't have the Mocha binary executable because Mocha brings this little executable for you that loads up all your test files and does all the work to sort of prepare all of your test files. So let's make the foam file here do that. Or let's actually make, yeah, let's do that. So foam here is going to be our test suite. Or was it the other way around? Yeah, let's make this one the test suite. The Mocha clone. And then we'll make this red eye be the chai expect clone. Everybody following this so far? Yeah? Okay, so what we ultimately want to do is we want to say node, well, actually we will, we're going to make this executable. Ultimately, we want to be able to say foam.js and then calculator test, just like the Mocha command, right? But instead we'll do this foam command. Does that make sense? No? I'm seeing some like confused faces. That's why I keep asking. Who feels lost? Nobody? Okay, I'll keep going, but please jump in if you have questions. Great. Okay, so in order to make this executable, we have to put a shebang on the top of it like that. And console.log, hello from foam. Cool. And then we're going to chmod and give foam executable permissions. So now it's got this little X right here, and my terminal shows it as red. So now we can just execute it as it's self-contained executable, just like the Mocha command. Yes.
Can I ask you, so when you say I download your testing suite from GitHub,
Sure.
is the foam still going to be have that permission in my computer?
Git does track and store file permissions. So if you clone something from GitHub, it should maintain file permissions. And if you change the permissions of a file, you have to check that change in.
But if I just copy paste it from your computer,
Copy paste what?
Like if I copy and paste the project in a flash drive.
So when you say copy paste, there isn't a real copy paste to do here. You can't go to GitHub and copy a GitHub repository, right?
Outside of GitHub, I'm saying if I go to your computer,
Yeah.
and stick in a flash drive, copy the project.
It depends. When you copy files, you can copy files in a way that maintains their permissions or ways that do not. It depends on how you do the copy. Yes.
Doesn't Node give you that permission to execute the file? Like, why would you have to give it permission like on line one, you don't actually to execute the file?
Because you cannot execute a file without giving it a shebang, or at least not a node file, and giving it executable permissions.
Is that already Node that gives you like?
I would have to say node in front of it.
Oh, okay. In this case, you have to execute the file.
I'm trying to replicate the Mocha command. So we normally would do like Mocha calculator -test. That's how normally. Right.
If you call node first, the node already has executable permissions.
Exactly. Yeah. So I'm trying to replicate this. We normally would say Mocha run this test file, and I'm trying to say, well, we're going to write our own Mocha, so we'll do foam.js.
Question. Is there a way to, like, say you create a shell script?
Yeah.
Throw it in your
Sure.
instead of having to type out the
Yeah.
Is there a way to do that for JavaScript files?
Any file. It's irrelevant what type of file they are. Any executable file that's in your path, in your array of paths in the path environment variable are executable and findable.
Okay.
So yes, there is a way to do that. There's totally a way to make, and I think there's a module for it to like make your own bin directory and make your own scripts and put them in there. Cool. All right, so we have foam. It's executing. It's saying hello from foam, and now we need to take the paths that it's giving us to know which files we need to execute. Right. So we're going to say process.argv.slice2, I think. And we'll see if this gives us an array of our test files. It does. If I had another one here, we'd get 2. Yeah? Cool. So now we have our test files, and we need to execute each of those files. So I'm just going to go through here. I'm going to use an arrow function. And we are going to, I'm not sure if we're just going to require this file or whether or not we're going to, right now I'm just going to require it. I'm actually going to use path here to make sure I get the right path. And we'll say path.resolve dir name, comma, test file. Okay, so this should take the test files that I give as arguments, and it should try to require each one of them. Cannot find module foam. Oh, because this thing's still trying to require foam, and it's /foam. So this is working, right? It's actually requiring this file. We know that because we got an error from trying to execute that file. Now it says describe is not defined, okay? So this is one of these things that I'm going to describe that Mocha does as a global function. Mocha creates a global variable. It actually violates what I think is the community's preference around libraries, but Mocha violates that and just says, like, whenever you call Mocha, you're going to get this global describe. Otherwise, we'd have to require describe, right? Like we're requiring everything else. But let's keep cloning Mocha, even though it probably would be better if we were requiring describe, but that's how Mocha works. So let's keep doing that. So Mocha has a describe function, and this takes the I don't know, target description and the handler function.
But since the test that you have in your test file are being called from within the Mocha file, aren't they already not global, but like scoped to anything that calls?
There's no scoping that goes through a require.
Okay.
How you require, so like the requiring of things does not, how you require something and where you require something from shouldn't have an effect on the end result of the requiring, right? It shouldn't be able to require in 2 different ways that create a different output, right? If I do the same require, I should get the same thing. So here we're creating a global variable so that when we require this file down here, it already has that thing. We can't require in a scope or anything like that.
Okay.
So we should get no errors now because that very first describe is being called. It exists now, but the handler function doesn't get called. Therefore, this second describe and all the stuff that's in here isn't being handled, right? Make sense? So we need to start building a system now that's going to allow us to say, okay, we need run this handler that you gave us, and if we see another describe, we need to start like building up like a tree that represents this like testing structure that Mocha's creating, right? So we have a describe, and then nested inside that is another describe. This should actually just be add here. So describe calculator, then describe add, and then we have 2 it blocks. Yeah? Make sense? Cool. So how are we going to do that? Because this describe is the same as this describe, so we have to do some nesting. So I'm going to do I don't know how I'm going to structure this. I'm making this up, but I want to store something like how I'm trying to figure out a way how we might be able to store these 3 calculator plus add plus should take, right? Because if we look at how Mocha does this, let's do it that way. So you see how we have to like store these 3 pieces of information? calculator nested in calculator add. So we need to store that in such a way that at the end down here, we can actually say like run all the tests. So here we just want to collect the tests. So I'm going to take this target description and I'm going to make and now we get another error. It is not defined, so we need another global it. And this is the behavior description and the handle. And so this is the actual test that we want. So tests push this slice with nothing in it clones an array. So basically what I'm doing is every time you call describe, I'm keeping track of what you're describing by pushing it onto this array. So this first describe stores calculator. The second describe stores add. Then when we hit an it, we keep a copy of what the descriptions were at the time. So we keep a copy of calculator and add. And then we keep a copy of these three things. So what I should get at the end is two tests pushed into this array that have calculator and add as their sort of pre-descriptions. Does that make sense? And so we'll build our test suite out a little bit more so we can see this tree. So if I describe subtract with an it block should minus stuffs. And then I describe multiply, it should multiply given numbers. And then we log the tests that we found. We now have a structure like this, where this is our first test, should take numbers and return their sum, and it's describing calculator add. This is describing calculator add, second it. This is calculator subtract, and it's the third it. And this is calculator multiply, and it's the fourth it. So do you see how I'm taking this code down here as it's executing in some like nested functions, and I'm keeping track of the depth of our descriptions by putting them in an array that changes up and down. As we go down into describes, this array gets longer, and as we come back out, the array gets shorter. And then every it block knows whether or not we're inside of these two describes or this calculator and subtract or calculator and multiply. So each it knows, and then we'll store whatever its tree depth was at the time. So we should be able to get some output that looks like this, where we print out this output like this by saying, instead of just logging an array, we'll say for each test, we should be able to log something like Mocha's doing this in like a little tree fashion here, but you can see how we have that full structure here, right? Calculator, subtract, should minus stuff. You see how I'm storing each one of these? So this is a little bit complicated. There's a bunch of moving parts. So let's pause here and see if anyone has any questions.
Yeah, can you go to line 12 and 11 and 13?
These?
Yeah.
What do you want to know?
what is going on there?
So when line 4, so first foam runs, and then we get down here where we're requiring our test file here, right? And then eventually our test file calls describe. So describe gets called, and the word calculator, the string calculator, is sent here, which is pushed into this array. And then the function is that it was given is executed right away. So now we're inside of line 5, which calls describe again. So now we push add into descriptions, and we call the function. So now we're on line 6, and it calls it. And so we take this string here as behavior description. We take this function here as the handler. We do not call it. We just store it inside this object that is pushed inside of the tests array. And then it completes, and we call it again, and we store another test. And then this describe completes, and the word add is removed. And so now we're back to just having calculator inside of descriptions. Okay? And then this describe calls again, and so descriptions now contains calculator and subtract, and then it calls the handler, which is this function, which then calls it, which stores should minus stuffs, plus a copy of this, which says calculator subtract. Does this all make sense?
I know.
No?
It makes sense, but yeah, it's hard to understand it in like one shot. But
Yeah, it's hard. Like, there's a lot of stuff going on here. There's like a nested tree structure of functions being called inside of functions, right? And being given handler callbacks that get called, which call more. There's a little bit of recursion going on here. But I'm storing all of that data, and I'm representing it in some data structures here that allow me to keep track of the depth of my describe tree. This is a temporary variable that I'm using to keep track of like how many describes am I inside of, right? This is probably better to be called like the describe stack or something like that.
is there a reason why you did not make that an array of, description and function object?
Because I'm just calling the function. I'm not calling it later, I'm calling it right now. I don't need to store this, I need to execute. So this might be easier if we forget about the testing part of this, right? We just want this. Here's a structure, we don't need this either, or this. Here's a structure using just describe and it, and what we want is to capture the details of this as it's executed and output some tree-like thing like this, okay? So I'm actually realizing that even though the way I'm storing it here with it, which is each individual test knows its full history. It knows that it's inside of each individual describe calculator and describe add or subtract or multiply. It's actually not going to be easy for me to print out this structure here in a tree-like structure. So we'll try something different. What if we just print? What if instead of keeping descriptions, we'll just call, we'll say describe depth. So here's describe depth that starts at 0. And then we'll have it subtract after we call the handler. And then we're going to have it console.log. So this is just going to print out all the describes in a tree, if I can get it to work. Where was my join? Oh yeah, this thing down here. Okay, cool. So we have kind of a little tree thing going on here. Let's add something. Let's add another nested describe. All right, so let's dig into this. So here is an example of using these two global functions. And then here's an example of the tree that they express, right? Does everyone see how this tree on the left here is it a representation of what's going on over here? And if I keep going deeper, we should get deeper output over here. So let's dig into this. Let's make sure everybody understands this.
Can I ask you something?
Of course.
This might be one approach, but would this be another? Would you consider when you write your describe function, maybe you say if the callback has to describe if it has it blocks like to the do the catch try catch block, and if it has another describe call itself yeah.
You can't look inside a function and say, does this function call it? Does this function do this thing? If so, do a different thing. That would be really, really hard to understand what your program did if every time you gave something a function, it was like, I'll do something different depending on what your function does. Like, that'd be awful. So you're thinking about the computer being an intelligent actor here, when really it's just like dumbly following your instructions, right? We need to look at this is a flow control challenge here, right? This is a challenge for us to look at this code and figure out what's being executed in what order, right?
I mean, effectively, that's what you're doing, but like through code. Like you're saying, like if handler is a describe function, then call describe again. But if handler is an it function, then it calls it. Like it's
Yeah.
It's
This
not looking in the function. It's just calling whatever the function is.
correct. It's blind. It. When we say it, I'm not sure exactly. We need to be more specific about what we're talking about as it. When we say it, are we talking about like the JavaScript environment, the executor, the thing that's executing? Right. So this is a series of instructions, right? That this thing doesn't know anything about. It's just it's the definer of describe and it, right? But it doesn't know the order of which things are going to happen, right? So once this outer describe is called, it's going to receive this as its second argument and call it, and it has no idea like what road we're going down. Are we going to call describe 20 times, 2 more times? Is it going to be called 100 more times? Like, it doesn't know. This code over here just needs to be prepared for any combination of it and describe happening. So instead of storing these tests, I'm actually going to, I think I'm going to run them in line, because I'm going to make this copy of Mocha only support synchronous testing. It's not going to support asynchronous testing. We're going to get to that at another time. There we go. Okay, so here is the tree printed out here as it was described by this code here. And you can see I'm no longer using any of these stored variables. I'm only using depth to store now, is the only thing that I'm storing now, to know how far in the tree we are. So this is a little bit of a simpler implementation, and we can get away with this because it's only going to support synchronous testing. So what we do now with the describe is we just print out what your describe was and we call your handler. And then if we run into another describe, right? So we start off with describe calculator, and then we run into describe add, and now we're 2 levels deep, and then we hit our first it. And here we're going to run our it block, which we don't have any it blocks. So does everyone feel satisfied in understanding how this code is being, and this code works together to produce this output? Any other questions about that?
Can we look at the describe and it functions one more time?
Which functions?
The describe
They're right here. Yeah.
Okay, cool. So what you're doing is you're getting a description and a handler function, So you're increasing the depth, then you're giving yourself indentation with the P described depth, and you're also printing out the test, and then you're calling the handler function,
Yep.
and then you're indenting it back to what it was before the describe block. Okay, that makes sense. You're calling the handler from describe, but
Right.
it is a function that takes a description and the handler as well.
Well, right now the handler for it, we're not doing that yet. We're good. That's where we're gonna go next.
Okay.
Okay, but for now, keep in mind that the first describe is here, and we go to describe depth 1, and then immediately we call handler, and then handler calls describe, so we call describe again, and now we're at describe depth 2, right? And then that calls it, and then this handler, the second handler, this one completes, and we go back to describe depth 1, and then we hit describe subtract, and we go back to describe depth 2. Right? And we go down, down, up, down, up, down, 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 up, 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 right? As we go down the list of the file on the right. Okay, so now let's pretend that I'm actually gonna go get a thing called chalk for some color, so we can have some nice color. And I think we're just, and so let's pretend, let's just say, let's just do, here, I'm going to make this a little function. And does this still work? Great. So let's get some color in here. So for these things, I'm going to say chalk dot green or chalk dot blue. And down here, I'll say chalk dot green, I think. There we go. A little easier to read, yeah? Okay, so now if these tests, so we have an example of this depth here, so I'm going to get rid of this. Okay, so now if this test were to pass or fail, I'm going to do either green or red, yeah? Okay, getting a little closer here. So how do we know if this test passes or not? So let's find out. Let's give this, oh, actually, this is actually really nice. So if there is no handler, then we're just going to log this. As yellow, because it'll be considered like a pending test. And we'll put like something like that in front of it. Oh, not there. Not helpful. Ugh. There we go. Okay. So we'll just put pending at the end of it if it doesn't have a handler, right? So now all these are pending, so I'll give this a handler. So we'll talk about multiply. And now it has a function. So we should figure out whether it passed or not. So what we're going to do is we're going to say try, and we're going to call the handler, and we're going to say catch E. And if we get here, it means we passed. And if we get here, it means we failed. And this is just description. All right. See how I'm using the try catch now? So we're going to try and run the handler. Whoa. Oh yeah, here we have to return. If there's no handler, we just say we're pending and we return. We stop. There we go. Okay, so they're all pending except for multiply. We called and it didn't raise an error. Yeah? But if we throw an error, it comes out as red and we say test fails. I'm actually going to not
But we wanted that logic inside the phone, right? The try catch.
No. The try catch is about Mocha. So foam is the Mocha clone, right? So foam is going to run a test and decide whether it fails or not.
What is expect as in try.expect? What is our assertion?
Expect is going to be red eye. It's going to be this library we haven't even worked on yet. I'm going to forget about the error message. Let's just decide whether it passed or failed. Okay? So this is a failing test because it threw an error, and this is a passing test because it didn't throw an error. Right? The fact that an error is or isn't thrown is going to be handled by red eye. This is the copy of chai expect. Right? We're going to do something different there. Okay? So let's do that. Let's bring in our assertion library. So we'll say red eye equals require, and we're actually just going to use some assert functions. So just like we did in our other thing here, we're going to actually have to get the calculator, and then we're going to say that calculator add 10 and 5 should equal 15, right? So we're just going to do red eye dot assert. Actually, let's just copying expect is going to take more time than we have left. So I'm just going to do some simple assert functions. So let's just start with assert as a simple function. Everybody's used assert before. So we're going to say assert that calculator add is equal to 15. Otherwise, expected 10 plus 5 to equal 15 will be our error message. So this assert function, right? It doesn't exist yet. Does everybody know how this should work, though? Anyone want to say how they think this should work? How should the assert function work?
It takes in two arguments. The first argument is true, then it returns true. If it doesn't return true, it throws the error. That's the second argument.
Yeah, that's close. Assert takes some sort of first argument, and if that is a truthy argument, it does nothing. If it's a falsy argument, it throws this as an error, right? So we can actually go into our red eye file here, and we can just say module.exports equal or .assert is a function that takes a result and an error message. And if the result is not truthy, then we will throw a new error with that error message. So this is it. If whatever you gave us is ever false, we'll throw that error. That's it for the assert method. So we can see that calculator add 10 and 5 should give us a passing test. Oh, it's a // and / calculator. There we go. Okay, so we ran, and I'll put a console log in here. So our first it block was run, and it didn't throw an error, and so it came out green. Okay, if it was an error. If we said that 10 plus 5 should equal, 10, then it throws an error and our test is red.
Can we also print out expected actual values?
What do you mean?
If a test fails, we're going to say test expected.
Yeah, so if this was wrong, if we thought 10 and 5 was supposed to produce 7, or let's actually just mess up the calculator. So here's our calculator, and we'll make it. We'll mess up the add function here. So we see that our test fails, but it doesn't print out the error. So that's a responsibility of Mocha. Our clone is Foam. We should have had better names here. And so here we'll just output the error message in, I don't know, orange or something like that. It's not going to look pretty, but we don't have orange. I don't know, gray maybe. So expected, and we'll give this thing a little indentation here too. There we go. So expected 10 plus 5 to equal 15. That's our error message that came out of our test suite here. Right? So if we had a different error, right? That comes from there. Yeah? So this is actually a pretty good, simple overview of what Mocha and Chai are doing. Right? We can get more complicated with our assertions, right? When we do like expect this to equal that, we could do like assert equal as a different testing method. So now we would just pass in the two things that are supposed to be equal. And then inside of red eye, we could make a more specific selector, which will say like assert equal takes A and B, and if A does not equal B, then actually what we'll use is assert here. So inside of assert equal, we're going to say assert A is equal to B. Otherwise, we'll say expected B to equal A, or however way you want to put it, right? So now we're using assert by assert equal to say if these things are not equal, yeah, if this is false, then we'll throw the error expected B to equal A. So we should get expected, oh, we're not using our assert. Oh, we still have a messed up calculator. Let's fix our calculator. And now we have no errors. But if we had an error, right, expected 10 and 15 to equal 15, it would say expected 15 to equal 25. So now we can start building up more and more complicated assertion functions, or a really complicated thing like expect. And all we have to do is make sure that they throw errors if they ever fail. So we can do minus, right? Expect calculator minus, this should be 5, right? And so this will throw an error saying calculator minus is not a function. We have a nice error message here. And so if we go add minus, we get a passing test. And if minus was broken, we'd get expected 5 to equal negative, nah. And I think it's actually the other way around. That makes more sense. We expected that to equal 5. There you go. Cool. So you see these two things and how we're doing totally different jobs?
Can we look at the code one more time?
So it's not that Mocha and Chai are like terribly complicated libraries, just that it's gonna be a pain to do this every time by yourself.
Exactly. Yep. And it's more complicated than I'm able to do in an hour here.
Right, yeah.
Especially when we talk about asynchronous tests and stuff.
Right.
Mocha's doing a pretty good job of accomplishing a complex logic problem, right? So we don't have to. Yeah.
So you could, if you wanted to make your assert equal, do like a DP. Right? That's where you would do it if you want to.
Yeah, if we wanted to write our own deep equal, right? This is where we would write deep equal. And then inside of this function, which is something that Chai does for you, is we'd have to say, like, what type are A and B? Are they arrays? Are they objects? And if they are, we have to recursively traverse down them and check every value for equality, right? So the Chai deep equal is probably actually some really complicated logic.
Can we do JSON.stringify for A and B?
You can, but that won't. Not all data in JavaScript can be turned into JSON, and some data will be normalized, right? JSON only supports null. It doesn't support undefined, so any undefineds will be removed from your JSON structure. And so, like, you wouldn't be able to successfully compare two objects that had properties with undefined values because those would be removed. You know, so like it's not perfect. It's one way to check. If you know your data and you know your data is serializable by JSON reliably, then that's one approach, is turn them both into JSON strings and compare those strings. They should be the same. But when you have things like objects which have keys and properties that aren't necessary, they aren't ordered, right? Objects don't have orders to keys and properties. So when you to-JSON them, if they come out in a different order, the strings will be different, but the data will be the same. So you got to be careful about how you compare stuff. And that's why we don't want to write this stuff ourselves if someone else who worked harder on it can do it for us, right? The deep equal in Chai, I totally trust, and I wouldn't bother questioning it unless I saw some real good evidence that these two things should be equal, right? So we definitely don't want to do what we just spent an hour doing. There's someone has spent a lot more time and made a much more reliable test suite tool for us in both the cases of Mocha and Chai. But do you want to go read the code for Chai's deep equal? Sure, totally. Go read it. See what they're doing. See how hard that problem really is. Cool. I hope this was helpful in understanding the roles of Mocha and Chai and how you might better use them and see the difference between them. All right. Thanks, everybody. I'm going to end this one a little early. Cool. Have a good lunch.